A neighborhood of a point A is an open interval containing the point A it is generally denoted by a minus lambda comma a plus lambda. Also x belongs to a minus lambda time comma a plus lambda. That implies x minus a mod of x minus a less than delta. Delta I मैले के भने delta. As we have seen that limit x tends to a f of x equal to L means fx approaches L as x approaches a, or the difference between f of x and L. That means mod of f of x minus L is very small when the difference between x and a, that means x minus a, is very small. We can use epsilon and a delta. Firstly, we have to understand the concept. Now the exact definition of limit we will be discussing now. Definition for the examination or to study. While defining what is limit, let f of x be defined in a neighborhood of a of a f of x may or may not be defined at x equal to a, then f of x is said to tend to the limit L is x approaches a. Symbolically, limit x tends to 0, f of x equal to L if to every positive epsilon, however small, there corresponds a positive number delta such that f of x minus L less than epsilon whenever x minus a less than delta. Now we can verify this definition with an example, dear students. You have to write this definition in your examination. Define limits. If we need to define the limit, you need to write this. Now let's discuss this by an example, dear students. Question is, evaluate the limits and verify the result that limit x tends to 2 to x plus 5. Now the solution of this, we have limit x tends to 2 to x plus 5 equal 2 times 2 plus 5 equal to 4 plus 5 equal to 9. Firstly, we can find easily. The limit is exist. Now we have to verify the result. So now corresponding to epsilon greater than 0, we find delta greater than 0 such that f of x minus L less than epsilon whenever x minus a less than delta. This is conceptual questions. You have to study deeply. That is, f of x minus 9 less than epsilon whenever x minus 2 less than delta. Therefore, f of x minus 9 less than epsilon, or what is f of x? 2x plus 5, 2x plus 5 minus 9 less than epsilon, or 2x minus 4 less than epsilon, or 2 common x minus 2 less than epsilon, or x minus 2 less than e by 2. Thus, we take delta equal e by 2 so that when x minus 2 less than delta, that implies f of x minus 9 less than epsilon, hence verified.
सर एक्चुअली पहिला को स्लाइड देखाइदिनु न एकचोटि
Okay.
ओके सर
The definition, that second I have written the definition which is verified from this example. It is very, very, very important in every aspect. Okay, can you move to the next? You can take another example and you can verify. It is very important. Eh? Now,
यस्तो छु त एकचोटि
sorry.
भयो भयो
Okay. Now, right hand limit and left hand limit. Right hand limit and left hand limit. We may have different definition, but the meaning is same in different books. Anyway, we can consult one book and we can study the definition in that way. Okay, dear students, what is right hand limit, what is left hand limit, and some notes also we can write here. Firstly, a function f of x is said to have the right hand limit, L1 at x equal to a is x approaches a through value greater than a. That means x approaches, from diagrammatically we have discussed, approaches a from the right, and symbolically it is written as limit x tends to a plus f of x equal to L1. The right hand limit of f of x at x equal to a is also written as limit x tends to a plus f of x or f a plus 0. We can write in this way also. For this definition, please copy this. Now the next definition. Now the second definition, dear students, about left hand limit. A function The pattern is same. A function f of x is said to have the left hand limit L2 is x equal to a is x approaches a through value less than a. That means x approaches a from the left. From the left. And symbolically it is written as limit x tends to a minus f of x equal to L2. The left hand limit of f of x at x equal to a is also written as limit x tends to a minus 0 f of x or f of a minus 0. Here also limit x a plus 0 we can write. Okay. And the last and very important point is limit of a function if exists is a unique finite real number. It is unique finite real number. Limit of a function if exists is a unique finite real number. It is another important point, dear students. Okay, it is another important point. Question goes like this: calculate the limit of the function f at the point specified below, where f of x equal 5x plus 2 for x greater or equal than 2 7x minus 2 for x smaller than 2, 8x equal to 2. This is the solution. Question. Now the solution is, dear students, here we have given the function f of x equal 5x plus 2 for x greater or equal than 2, 7x minus 2 for is smaller than x is smaller than 2. It can be solved by two techniques, two methods. I will show you both methods. Anyway, first of all, we have to study the function. There are two functions given, two conditions given within this function. If the x 8.2, the point specific point is 2, and this condition is given, you can take fx equal to 5x plus 2 function. This function you can take for x greater or equal than 2. 2 भन्दा माथिको भ्यालु छ x को लागि हो भने यो माथिल्लो फंक्सन लिनुहोस्. 2 भन्दा सानो x को भ्यालु को लागि यो फंक्सन लिनुहोस्. इट रिफ्लेक्ट्स, यसले के बताउँछ भन्दा हामी लेफ्ट ह्यान्ड लिमिट यो पार्टिकुलर पोइन्ट भन्दा साना पोइन्ट तिरबाट एप्रोच हुने भएको हुनाले यो फंक्सन हाम्रो लेफ्ट ह्यान्ड लिमिट को लागि हो, र यो पार्टिकुलर पोइन्ट भन्दा ग्रेटर भ्यालुबाट एप्रोचेस हुने भएको हुनाले त्यसलाई राइट ह्यान्ड लिमिट को रूपमा लिन्छौं. यहाँ 2 एक्ज्याक्टली 2 or मोर देन 2 को लागि यो फंक्सन लिनुहोस् भन्न खोजेको. 5x plus 2 हामीले राइट ह्यान्ड लिमिट को लागि लिन्छौं. अगेन आई वान्ट टु रिपिट, x is smaller than 2. The specified point is 2 where x are smaller than 2. That's why the function is suitable for left hand limit. Right, and here the x are greater or equal than 2. So we need greater for right hand limit, equal for functional value that we will be discussed later on in continuity. So we should take this for right hand limits. So the solution is, for left hand limit 8x equal to 2, limit x tends to 2 minus f of x equal limit x tends to 2 minus, which is for left hand limit 7x minus 2. 7x minus 2 equal 7 times 2 minus 2 equal to 12. And for right hand limit 8x equal to 2, dear students, limit x tends to 2 plus f of x equal to limit x tends to 2 plus, we should take this function 5x plus 2 equal 5 times 2 plus 2 equal to 12. Since left hand limit equal to right hand limit equal to unique real number 12, therefore limit x tends to 2 f of x exists. Now it can be done by alternative method. The alternative method is let h is greater than 0. Now f of 2 minus, this is for left hand limit, limit h tends to 0, f of 2 minus h, in definition I have explained about this, equal limit h tends to 0, The function for left hand limit is this. So 7 times x is replaced by 2 minus s minus 2 equal to h is 0, 7 to the 14 minus 2 equal to 12, and f of 2 plus equal limit s tends to 0 f of 2 plus h, यो राइट ह्यान्ड लिमिटको लागि equal limit s tends to 0. We should take right for this function for right hand limit. So 5 times 2 plus h plus 2, when h is 0, 5 to the 10 plus 2 equal to 12. Since left hand limit equal to right hand limit equal to 12, therefore limit x tends to 2 f of x like this. So we can use this one-sided limits involve limits of a function with just one side, either to the right of a certain value or to the left of a certain value. If we are looking for a limit to the right or left of a function respectively, we will have an equation like this: limit x tends to a plus or limit x tends to a minus. This is for right, this is for left hand limit. We will still solve by working that value in first. If that value turns out to be 0, we need to manipulate like before, that we have already discussed. Here is an example problem of a one-sided limit. Limit x is to 3 plus x square minus 9 by x minus 3. This is an indeterminate form. So we have to factorize this using formula x plus 3 times x minus 3 by x minus 3, x minus 3, x minus 3 cancel. And limit x to 3 plus x plus 3, 3 plus 3 equal to 6 is answer. In this way you can find one-sided limit. Next question. Find the limit at this point specified. Find the limit at the point specified. Number A, f of x equal x plus 2 for x greater or equal than 0, for x plus 2 for x smaller than 0, 8x equal to 0. This is the question. Now the solution is let f of x equal x plus 2 for x greater or equal than 0, for x plus 2 for x smaller than 0. And now for left hand limit 8x equal to 0, limit x tends to 0 minus f of x equal limit x tends to 0 minus, for left hand limit specific point is 0, x are smaller than 0, so it is approaches from smaller value than particular point. So the second function for left hand limit we have to take. So here 4x plus 2 equal, now we can apply the limit. 4 times 0 is 0, it is 2. And for right hand limit, 8x equal to 0, limit x tends to 0 plus f of x equal to limit x tends to 0 plus the value are equal or greater, so we should take x plus 2 for right hand limit, x plus 2. So now apply limit 0 plus 2 is 2. Since left hand limit equal to right hand limit equal to 2, therefore limit x tends to 0, f of x exists. This is by one method. Now we have alternative method also. In grade 12 we will solve by second method probably. Now I will solve by second method, means technique. Same problem by different method, means approach, but both are right. Firstly, let s greater than 0. Now f of 0 minus equal to, this is for left hand limit, that's understood, limit s tends to 0, f of 0 minus h equal limit s tends to 0. What is the function for left hand limit? This is the function for left hand limit. So what can we do? 4 times 0 minus h plus 2 equal, so h is replaced by 0, 4 times 0 is 0, 0 plus 2 equal to 2. Looks similar, right? Again, f of 0 plus equal limit s tends to 0, 0 plus h for right hand limit, 0 plus h particular point plus h value where h is greater than 0, particular point minus h for left hand limit where h is greater than 0. Then limit s tends to 0, you have to take this function. X is what? X is replaced by 0 plus h. 0 plus h plus 2, like x plus 2. This is x replaced by 0 plus x, 0 plus h. So h is 0, 0 plus 2 equal to 2. Since left hand limit equal to right hand limit equal to 2, therefore limit x tends to 0, f of x exists. यसरी हामी लिमिट एक्जिस्ट भयो कि भएन भन्ने कुरा राइट ह्यान्ड लिमिट र लेफ्ट ह्यान्ड लिमिटको सहायताबाट फाइन्ड आउट गर्न सक्छौं. We have discussed first class work, second class work, third class work, and fourth class of today.
Dear students, we'll be discussing more other question so that limit x tends to 2 mod x minus 2 over x minus 2 does not exist. Solution: let f of x equal mod x minus 2 by x minus 2 for left hand limit at x equal to 2, limit x tends to 2 minus f of x equal limit x tends to 2 mod x minus 2 over x minus 2 equal limit x tends to 2 minus x minus 2 over x minus 2. It gives to value. We know absolute value definition: minus x if x is smaller than 0, x if x greater or equal than 0, so that it gives two values. If it is x minus 2 less than 0, then mod of x minus 2 equal to minus x minus 2. You can quote limit x tends to 2 minus 1 equal to minus 1. For right hand limit at x equal to 2, limit x tends to 2 plus f of x equal limit x tends to 2 plus mod x minus 2 by x minus 2 equal limit x tends to 2 plus x minus 2 by x minus 2. It gives the positive value if it is greater or equal than that. Then limit x tends to 2 plus 1 equal to 1. Since left hand limit does not equal to right hand limit, so limit x tends to 2 f of x does not exist. Now the same question can be done by another process. Let me show that process as well. Question is same, that is so that limit x tends to 2 mod x minus 2 by x minus 2 does not exist. This is the question. Now the solution is let f of x equal mod x minus 2 by x minus 2 for left hand limit f of minus 2 minus equal limit s tends to 0 f of 2 minus h equal limit s tends to 0. Here x means was 2 minus h, 2 minus h minus 2 over 2 minus h minus 2. This x is replaced by 2 minus x. That's why 2 cancel. Minus is mode is plus h over first limit h tends to 0 h over minus h equal to limit h tends to 0 minus 1 equal to minus 1. For right hand limit ff2 plus equal limit h tends to 0 2 plus h equal 2 plus equal limit s tends to 0 2 plus s minus 2 over 2 plus s minus 2 limit s tends to 0 s by s equal limit s tends to 0 1 equal to 1. Since left hand limit does not equal to right hand limit, so limit x tends to 2 more x minus 2 over x minus 2 does not exist. In this way we can solve this question and similar question as well. Now we have to move the next question. Next question is show that limit x tends to 0 1 by x does not exist. Solution: let f of x equal let f of x equal f of x equal 1 by x. For left hand limit 8x equal to 0, limit x tends to 0 minus f of x equal to limit x tends to 0 minus 1 by x equal to 1 by minus 0 is minus infinity. For right hand limit 8x equal to 0, limit x tends to 0 plus f of x equal limit x tends to 0 plus 1 by x equal 1 by 0 equal to plus infinity. Since left hand limit does not equal to right hand limit and both also does not exist, so limit x tends to 0 1 by x does not exist. Now next question, let me highlight next question also. Question is prove that limit x tends to 0 mod x by x does not exist. Solution: that we have done similar question as well. let f of x equal to mod x by x. Now by alternative method, f of 0 minus equal f of 0 minus h equal limit h tends to 0, 0 minus h by 0 minus h equal to limit h tends to 0, h by minus h equal limit h tends to 0 minus 1 equal to minus 1. And again f of 0 plus is for right hand limit, f of 0 plus h equal limit h tends to 0, 0 plus h by 0 plus h, limit h tends to 0, h by h equal limit h tends to 0, 1 equal to 1. Since f of 0 minus does not equal to f of 0 plus, so the given function limit mod x by x does not exist. Okay, now we'll discuss very important question. The question is like that: evaluate limit x tends to 0 sine 1 by x if exist. Solution: we have to evaluate when x tends to 0 plus, that implies 1 by x tends to infinity, and x tends to 0 minus, that implies 1 by x tends to minus infinity, and sine 1 by x may take up any value from minus 1 to 1. Due to the lack of uniqueness, limit x tends to 0 sine 1 by x does not exist. It's very good concept. Now the next very important question is like this: so that limit x tends to 0, x sine 1 by x exists. Solution: when x tends to 0 plus, that implies 1 by x tend to infinity, and if x tends to 0 minus, that implies 1 by x tends to infinity minus infinity. Although sine 1 by x may take up any value from -1 to 1 and is not unique, or is not definite, but it is finite value, not the fixed, not the unique, not the definite, but it is finite. So limit x tends to 0, x sine 1 by x equal limit x tends to 0, x limit x tends to 0 sine 1 by x equal 0 times any finite value from -1 to 1 equal 0 times something is 0. Therefore limit x tends to 0, x sine 1 by x exists. We can solve, we can verify this question by this way. The same question by another method, dear students, so that limit x tends to 0, x sine 1 by x exists. Now we have to solve this by another way. We know limit x tends to 0, sine 1 by x does not exist. If and for all real x does not equal to 0, -1 lesser equal than sine 1 by x lesser equal than 1. If x greater than 0, where -x lesser equal than x sine 1 by x lesser equal than x, taking limit x tends to 0 plus on each of the terms, that it will be 0 lesser equal than limit x tends to 0 plus x sine 1 by x lesser equal than 0. Hence by squeeze theorem, limit x tends to 0 plus x sine 1 by x equal to 0. And in the first step we can be noted this limit x tends to 0 x sine 1 by x does not equal to limit x tends to 0 of x times limit x tends to 0 sine 1 by x. Because limit x tends to 0 sine 1 by x does not exist. Now the second part, similarly if x is smaller than 0 we have minus x greater than x sine 1 by x greater or equal than x. Taking limit x tends to 0 minus on each of the terms 0 greater or equal than limit x tends to 0 minus x sine 1 by x greater or equal than 0. Hence by squeeze theorem, limit x tends to 0 minus x sine 1 by x equal to 0. Therefore limit x tends to 0 exists. In this way the limit is exists. And for your self practice, number 1, so that limit x tends to 0 x square cos 1 by x exists, and 2, find the limit at the specified point if exist. The function f of x is x square minus 5x by x minus 5 for x does not equal to 5, 0 for x equal to 5, 8 x equal to 5, and 3 number question, this is 2I, this is 2I and 2II, 3. F of x equal to 1 over x minus 2 at x equal to 2. This question, I hope you will find the solution yourself. Thank you.